Computers and their programs are integrated into our lives at a scale we could not have imagined. Over the past 20 years, we have seen dramatic jumps in technological gains in areas of distributed computing, cloud computing, and AI improvements such as voice and face recognition and self-driving cars. In the next few minutes, let me give you a brief overview of the history of programming, and you will also learn the basics of how programming works. Computing dates quite far back in our history. Charles Babbage in 1822, while studying at Cambridge University in Britain, was working on bettering calculating devices such as navigation charts and astronomical tables, which at the time were used by many ships at sea. Babbage came to the realization that all these calculating devices contained various amounts of human error, and he wondered if there was a better solution. His solution was the difference engine. The difference engine used mechanical gears with numbers 0 to 9 etched onto their gaps, separated by gears' teeth. Its key function was to carry out one operation that was computed by manually moving hand cranks until the final answer was revealed. After building a working prototype, Babbage spent many years working on further improving his designs and constructing improved versions of the original idea. He created another device called the Difference Engine 2, but ultimately produced a new and better concept called the analytical engine. The analytical engine is widely accepted as being the basics of modern-day computing. Babbage's friend Ada Lovelace published a document describing how the analytical engine could perform a sequence of calculations, which is essentially what a computer program does. However, the analytical engine was never completed, and Babbage, like a lot of developers, did not invest in good documentation. With the historical side of things covered, let's now delve into understanding what programming is. Before I explain programming, it's helpful to understand how computers work at the most fundamental level. Computers only understand binary code, which consists of two digits, 0 and 1. This may seem quite strange at first, but with a little explanation, it will all make sense. 0 and 1 relate to different electrical states, similar to a light switch. 0 is equal to off, and 1 is equal to on. For example, in programming, when you calculate numbers, cost, or any arithmetic, you mostly use decimal numbers. Every program written needs to be converted to binary code or machine code. An example of decimal to binary conversion is decimal 1 is binary 1, decimal 2 is binary 1, 0, decimal 3 is binary 1, 1, and so on. A computer represents the binary code by using tiny electrical conductors called transistors. These transistors are housed inside the Central Processing Unit, CPU, which is essentially the brain of the computer. When a program is written using any type of language, it needs to be compiled or interpreted. The outcome is to turn readable programming code, for us, into readable programming code for the computer. It's essentially extremely hard for humans to read and understand binary, and therefore, using it is error-prone. It's far easier for us to read and write programming languages. So, what is programming? Programming is the ability to provide a computer with a set of instructions in a particular language that it can understand and perform those operations or tasks. In other words, you need to tell the computer what you want it to do in a format and language it can understand. Programming is a skill. The more you practice and learn, the better you become. At first, it can take quite a while to write straightforward programs. As you progress, you'll become more familiar with the language and how the logic and conditions should be applied. Programming is also a creative skill. That's because you can write computer programs to solve problems in many different ways. And that brings us to the end of this video. You now know the brief history of programming and how typical computer programming works.